morning, Algebra 2. We are going to be covering Lesson 63 and covering unit circle and radian measures. This is all over trig if you plan on moving forward into trig. So anyways, a lot of the information's in the book. I will attach a completed unit circle for you, and you can print it and reference it. So let's start with first things first. Angles can be measured two ways. So angles can be measured, can be measured in degrees. That's when we use the little bubble up top, and radians, which is when we use pi. So angles can be measured two different ways, and we're going to talk about how to go from one to the other. So, for example, if I know that pi radians equals 180 degrees, and I know that 2 pi equals 360, right? Because 2 times 180 is 360. So to convert from degrees to radians, I would multiply by pi over 180. To convert from radians to degrees, I would use that pi equals 180 degrees. Okay, so that is what we're going to do in this first part. I'm going to practice two with you, and then we will do the ones in the book. So example number 1, convert negative 30 degrees to radians. So in order to convert degrees to radians, I simply take the degrees they've given me, and I'm going to multiply, which is what I have up here, pi over 180. So this gives me negative 30 pi over 180, and then I can reduce, and that would give me negative pi over 6, because I get 1 over 6, and so I don't need 1 pi over 6, it's just pi over 6, or pi 6 radians, however you want to pronounce it, but that is the answer. So I'll put that on here. This means like multiply. Okay, now you could also just use your unit circle, but I will go over that in a minute. So let's practice the opposite. So convert 3, you know what, I'll use a larger one. Let's convert 5 pi over 4 to degrees. So I know this is in radians because I have the pi. Okay, I know 30's in degrees because of the little bubble. So to convert this, I'm going to replace pi with what it equals in degrees, and it equals 180 degrees. And then from there, I would use my calculator. So 5 times 180 divided by 4, and I get 225 degrees. Okay, so let's try the two in our book. So in part A, it asks us to convert 150 degrees to radians. So we'll look at the example I did with you. We took the degrees and we multiplied by pi over 180. So 150 degrees times pi over 180. Now I'm going to rewrite that. That's 150 pi over 180. And I'm going to reduce by, I'm going to say 30. Okay, so 150 divided by 30 is 5 pi, and 180 divided by 30 is 6. So my answer is 5/6 pi radians. Okay, part B. They'd like me to convert negative 4/3 pi. Oh, and by the way, this could also be written 5/6 pi. It doesn't matter. I like to just keep pi on the top, okay? So convert this to degrees. Now, I showed you a method. I think the fastest way is I know that pi is 180, and I know it's on top, right? Otherwise, it would be written on the bottom, over 3. And then I'm going to use my calculator. So negative 4 times 180, enter, divided by 3, and I get negative 240 degrees. So that is the first part, is converting angles from degrees to radians. All right, the second is using the unit circle to find exact values of trig functions. So on our unit circle, and I will attach this, I know that for a unit circle, the sine of theta equals the y value, the cosine of theta equals my x value, and the tangent of theta equals y over x. So I will attach, this is a completed unit circle, and I have color coordinated. Blue is the degrees, black is the units, is radians. Okay, so I've got degrees, radians, these are coordinates. So when I'm talking about x and y, I'm talking about the points in red that are on the outside. That includes an x and y value. So it's simply sine of that angle is the y value, the cosine of that angle is x, and the tangent of that angle is y over x. So I'm going to do an example or a couple with you, and then we'll do the ones in the book for lesson practice. So find the sine of 120 degrees. Now, I know that the sine of 120 is going to be my y value. So on my unit circle, I'm first going to find 120 degrees. So I'm going here. Here's 120. And so this is x, this is y. So the y value of this coordinate is root 3 over 2. And that's it. That's it, guys. Part 4, find the cosine of 90 degrees. Okay, remember cosine is x, so if it helps you, I like to write cosine of theta comma sine of theta. Like in basically replacing x comma y, so I know it goes cosine sine. Another way to remember is it's alphabetical. X comes before y in the alphabet, and C comes before S in the alphabet. So that's another way to remember it. So find 90 degrees on our unit circle. This unit circle is also in your book, and I'm looking for the x value, so here's the pair of coordinates. So I'm looking at 0. So x equals 0. Last, let's try a tangent one. What is the tangent of 11 pi over 6? Now, it's okay that this is in radians because our unit circle has both. So the tangent of this angle is y divided by x. So let's find 11 pi. So I wrote radians in black. So I'm coming all the way around to here, 11 pi over 6. And I'm going to record this whole point because I need both. So I have root 3 over 2, comma, negative 1 over 2. So that would mean my y value is negative 1/2 over my x value, which is root 3 over 2. And we can't leave it that way. So I'm going to rewrite this. This is 1/2, negative 1/2, divided by root 3 over 2. And to divide by a fraction, I multiply by the reciprocal. So this gives me the 2's cancel, and I get negative 1 over root 3. Now, I wish I could stop there, but we did cover a section on how to get the square roots out of a denominator. So to get the square root out of this denominator, I would multiply by the radical. Sorry that there is a glare in here. It's because I have some of the lights turned off. That gives me negative 1 root 3 over 3, and that would be my answer. So let's try the couple in the book. So sorry, that's part C and D. So part C says to find the cosine of 315 degrees. Now I wrote it up above earlier, but cosine represents our x value. So for all of these, I'm going to write a little note up here. Find on unit, whoops. All right, so on for 315, I'm going to find that on my unit circle. Here it is. Here's 315. I'm looking at the x value. So I see that x equals root 2 over 2. So that is the answer. Just simply finding the x value. All right, let's try part D. Tangent of 3 pi over 4. And remember, tangent is going to be the y value over the x value. So let's record that coordinate. So 3 pi over 4. So find 3 pi over 4. Should be in black. 3 pi over 4. I'm going to copy this coordinate down so I have it. So I have negative root 2 over 2, comma, positive root 2 over 2. So to write this, right, I would write the y value over the x value. Now hopefully you can already see that those are identical, but if you can't and you get stuck or there's a problem later like this, it's the top, right, divided by the bottom. And to divide by a fraction, I multiply by the reciprocal. And what do you notice? Well, these cancel and these cancel, but I'm left with a negative. Now, why do they cancel? Because negative 2 over 2 is 1. Technically, negative 2 divided by 2 would leave me with negative 1. So that is the answer to part D. Now, for part E, they'd like us to find the value for all 3 for 210. So they'd like us to find the sine of 210, the cosine of 210, and the tangent of 210. Okay, so let's find it first on the unit circle. So I'm looking for 210 degrees. So in blue, here's 210. I'm going to copy down the coordinates. So I'm going to copy that onto my paper. The coordinates are negative root 3 over 2 and negative 1 over 2. So here's x, right? Here's y. So the sine of 210 is simply my y value. Cosine is just my x value. But tangent, tangent's going to take some time. So the tangent of 210 is the y value divided by the x value, which means, right, my x value times the reciprocal, and that will leave me with a positive 2 over 2 root 3, which will leave me with 1 over root 3, and that means I'd have to multiply top and bottom by root 3. So my answer would be root 3 over 3. And so those are the answers to this problem. All right, the third part of our notes is determining the arc length on a circle. So if I have any given circle, if I'm looking for the measurement of a part of the outside, so for example, if I was looking for the measurement of this, that is called an arc. And to find the arc measurement, you're going to use the following formula. Well, I should have written it over here. S equals R times theta. Now let me specify what each of these pieces means. So S, and I'm trying to find my other pen. My apologies. Where did I put my blue? My blue pen. Okay, I don't know where the blue pen is. So, ready? Oh, here it is. S stands for arc length. I'm not sure why they didn't use A, okay? R is our radius, and theta is our angle in radians. So, for example, if this is the center, right, this would be R and this would be theta. So I would need those three pieces. But this is super important. Your angle has to be in radians and not in degrees. So there are three. So let's start with part, oh, I've been doing these in red. My apologies. Let's start with part F. So part F gives us a circle. And they've given us that this is, I believe, 8.5. And they've given me my angle, or actually they've told me that this angle out here is 4 pi over 3. Okay, so here's what I have. Now I need to find, if I want to find the arc, oh, sorry. And they're looking for the arc out here. Sorry, I'm reading in the dark. They're looking for S1. So that means they're looking for the measurement from here all the way to here. So S1 would equal our radius, which is 8.5, and I think they told us meters, times our angle in radians, and it's already in radians. They told me it's 4 pi over 3. So there, I don't have to convert anything. So this is my radius, this is theta. So I'm simply going to enter in calculator. But make sure your calculator is in radians and not degrees. So if you're using Desmos or a hand calculator, your phone, if you'll see here, I already have it. I don't know if you can see, but I have an RAD at the bottom, which means it's in radians. If you don't see, if I hit DRG, I can switch it from degrees to radians. You'll need to find that part on your calculator. So I'm going to do this in radians. So I have 8.5 times 4 pi, there's a pi button on your calculator, divided by 3. And I end up with 35.60. So 35, I don't know why I wrote a 4, even though I showed 5. 35.6 meters. So that is the measurement of the arc from here to here. So let's try part G. G has a circle that looks like this. They've told us the radius is 8 meters, and they've told us that our angle is 135, and they're looking for this arc up here. So they're wanting the measurement from this part all the way to here. But before I start this problem, I have to convert 135 degrees to radians. So we did it at the very beginning. It's when you multiply 135 times pi over 180. And then I'm going to reduce. So 135 and 480, I'm going to reduce. I know that they're divisible by 45. You can reduce it by 15, but keep reducing it all the way down. So 135 divided by 45, I get 3. And 180 divided by 45, whoops, divided by 45 gives me 4. So now I can find the measure of my arc. So this arc equals the radius of 8 times 3 pi over 4. And I'm going to enter that in my calculator, making sure that it is on or in radians. So mine already is 8 times 3 pi divided by 4. See if you can see that. And I get 18.85. meters. All right, last, it's talking about a clock. Says the minute hand of a certain clock is 15 centimeters long. How far does the tip of the minute hand travel in 25 minutes? Okay, so let's picture a clock. Here's right 12, 3, 6, 9. The minute hand, and let's see here, 4. So it is 25 minutes and it started up here. So they're looking for how far did it go from here to get to here. So this is kind of a tricky one. They're telling me this is my radius, but I have to find this measure here of theta. So I know that from 12 to 6, that would be 180 degrees. So I'm going to divide that by 6 to know what each, and that would give me 30 degrees. So 5 times 30 would equal 150 degrees. And I can simply use my unit circle. 150 is 5 pi over 6. So 150 degrees is 5 pi over 6. So the measure of my arc equals my radius of 15 times 5 pi over 6. And I ended up with approximately 39 centimeters is how far the hand traveled. That concludes our section. I'll go ahead and write down for homework what we're skipping. So for homework, skip numbers 15, 18, 22, 26, and 28. Thank you.